Ingestion is a totally different beast, and to understand ingestion, there are 5 concepts that are important to understand how inserts work, especially the immutable parts mechanism that ClickHouse has implemented, merges, reads, mutations, and the importance of the table design. Okay, let's see an example. Let's say we have this table, timestamp, ID, user ID, event type properties. But the important part is this one. Let me annotate it. Partition, okay? Partition by month. Now, let's say we're going to insert these 4 rows. And look at this. We have 2 rows in September and 2 rows in August, okay? So, what is going to happen? You're going to send this insert to ClickHouse, and ClickHouse is going to optimize the insert, and it's going to write 2 parts, 1 on each partition. Okay, we have 2 rows in September, 2 rows in August. Whenever you insert some data, it detects the partition key, it creates a part, and it writes this to disk. Then there is a secondary process that runs in the background, which takes smaller parts. Let's say you have other parts from other inserts, and it's going to merge them into bigger parts because this is going to optimize reads. The parts that got merged, they are marked as inactive, and eventually they are garbage collected. And on the other hand, there is other operations, which is called mutations, which is triggered by certain operations. For instance, whenever you do an update or a delete, what ClickHouse is going to do is going to take the parts involved in the update or delete. It's going to mutate them, deleting or updating the necessary rows, and create another part, okay? So this is the immutable parts mechanism of ClickHouse. So we've seen how inserts work in ClickHouse and how these 5 concepts, inserts and parts, merge, reads, table design, and mutations are related. And there is a balance you have to find when ingesting in ClickHouse. On one hand, you want larger parts for reads, but the larger they are, it's more expensive merging them. So you might think, okay, so let's ingest just bigger batches, so it's not necessary to do so many merges, but then you are increasing latency and you're going to need more memory to ingest that data. And last but not least, you need to be aware that schema and partitioning design is important, because imagine you partition by timestamp and you ingest 1 million rows for different timestamps. What ClickHouse is going to do is going to write a part for each partition key, which is going to be each timestamp. So you're going to have like 1 million parts. This is a very classical problem in ClickHouse that can take the cluster down, okay? There is another hidden problem, because since ClickHouse by design writes immutable parts, schema and especially partitioning is immutable, and changing it is hard. So taking into account these 3 things, the balance is really hard to achieve, okay? What do you do in these cases? You want to find that balance on having fewer parts of a right size, so you don't have problems in your cluster when ingesting at high throughput. You end up building an ingestion proxy that it takes to buffer some data and build those parts, okay? It also can take other responsibilities, like having a backpressure mechanisms when merges are getting slower than inserts, or have a queue when you have an ingestion peak and you want to hold the data while you scale the cluster, and other failover mechanisms that are not implemented in ClickHouse. What happens when the cluster is down? Do you want to lose that data, or do you want to have a mechanism so you can replay it later, okay? Usually, this is implemented as another component in your stack that takes care of all that ingestion. It goes through the load balancer, because in the same way that you root the reads, you can also route the writes to specific replica that just takes care of inserts. And also mention that sometimes you can replace that like specific or custom component with some Kafka actually. But it depends. I mean, there is trade-offs, of course. It depends on your use case, your architecture, because this has a specific protocol. It cannot, depending on your architecture, it can be cost effective or not. You might prefer something ad hoc. So this is one of the problems you might face when ingesting in ClickHouse at scale.